concept, right triangles. Hey, it's a right triangle. You're going to see a lot of right triangles in this class. Now, I know that at some point in your academic career, you took some math class where you had to learn about right triangles. So, Katoa, remember that. But maybe it's been a while, maybe you forgot, or maybe you never really understood it much in the first place, even when you were in that math class. That's okay. But if you've forgotten about right triangles, or if you never really knew about them to begin with, then you have to learn how to do it right now. You're going to need this skill all year long. Here's a summary of how to handle right triangles.
Look at all that stuff. What does this mean? I need more information.
If you understand perfectly well what all three of these points mean, if you're in calculus or something and this is old news, that's great. But if you need a reminder of how to use SOHCAHTOA, or if you've never heard of an inverse trig function, then the rest of this video is for you. A right triangle has three sides that we call the opposite, adjacent, and hypotenuse. The hypotenuse is the easy one to spot. It's always across from the right angle, and it's always the longest side. Question for you. On this triangle that I have on the screen, which side is x? Is x the opposite side, or is it the adjacent side?
There's x. It's there.
The correct answer to that question is, I don't know, or better yet, it depends. The two non-right angles are marked with Greek letters, alpha and beta. Which side is the opposite and which side is the adjacent depends on which one of these two angles you're looking at. Side x is adjacent to angle alpha. Adjacent is just a fancy word that means next to. Side x is next to angle alpha. But if you were looking at beta, then side x is not adjacent. It's not next to angle beta. It's across from beta. It's the opposite side. All you have to remember is that adjacent means next to, and opposite means across from. Now it's time for SOHCAHTOA. I know you've heard this before. It's a mnemonic to help you remember the three basic trig functions: sine, cosine, and tangent.
Wow. I'm going to pause for a second. There's actually 6 trig functions, but we only use 3 of them. Thank goodness. Right? One question I want to ask is, why aren't we messing around with this angle right here? We're talking about alpha and beta. If I go backwards just a smidge, it's right here. He addressed alpha and beta. How come we don't fiddle with this angle? Because we know what this angle is, right? This is 90. I want you to try something. I want you to type in cosine 90 into your calculator. See what that says. I want you to try something else. I want you to type in sine 90 into your calculator. Okay? If you don't know, calculator. Sine, cosine, and tangent are usually 3 big buttons somewhere on your calculator. It's not sin. Oh, Father, for I have sinned. I poked a badger with a spoon. Oh, what a hellish sin, horrible crime. It's not sin, guys. It's sine. Okay? Now, what did you find out when you typed in cosine 90 or sine 90? You probably found out something interesting, right? Yeah, we don't really worry about this angle because we know what it is. And trig functions, when you do sine or cosine, you know, they don't really give you something helpful. Okay, I'm going to keep going.
Now it's time for SOHCAHTOA. I know you've heard this before. It's a mnemonic to help you remember the 3 basic trig functions: sine, cosine, and tangent. Now, what is a trig function? I can put sine 30 into my calculator and hit enter, but what does that answer mean? Let's look at an example.
Okay.
Here's a 30, 60, 90 right triangle. We want to know the sine of 30 degrees. You can use a calculator sine of 30 degrees is 1/2, 1 over 2. Put it into a calculator, this is 0.5. What this means is that the side opposite the 30-degree angle is always going to be exactly 1/2 the length of the hypotenuse.
So this side.
If the triangle in this picture is 5 meters high,
This is 5.
its hypotenuse must be 10 meters long.
And that would be 10.
Its hypotenuse is 2 million kilometers long.
So this is 2 million.
The height must
This would be
half that,
1 million.
kilometers. If that ratio is not exactly 1 to 2, then it's not a 30-degree angle. That's all sine, cosine, and tangent mean. Anytime you know an angle, then you know the ratio of the sides of the triangle. Now, what if you know the length of 2 sides and you want to find the third side? That's simple. Just use the Pythagorean theorem. A squared plus b squared equals c squared.
So Pythagorean theorem is the thing. To Pythagorize is a verb, and I actually typed this into Google and found this cute little thing. But a wise man once told me, to Pythagorize is to invoke the Pythagorean theorem. And so you are doing Pythagorean theorem. So we may say Pythagorize, and it's a verb. Pythagorean theorem, if you Google this, brings up this neat picture, which is one of my faves, of these 3 squares, and they make a little right triangle. This is a naturally occurring thing, right? Pythagorean theorem is a squared plus b squared equals c squared, and c is always that longest side, which would make the largest square. There are calculators. This is one right here where you can enter things and it will do it for you. I would urge you to be careful here due to the fact that on the AP test you can't use these. So be very, very careful, but they do exist and they are here. Okay. I'm going to go back to him.
A and B, it doesn't matter, opposite adjacent. They're just the two that are not the hypotenuse. C is the one that is the hypotenuse. Finally, let's look at how you can use trig functions to find a missing angle. In this picture, we know that the side opposite angle A is 12 units long, and the side adjacent to angle A is 22 units long.
Jason.
How can we find angle A? Look at your calculator. It probably has a second function that makes buttons do 2 different things. So if you push second, then sine, you're doing the inverse sine, which looks like sine to the negative first power. In this case, relative to angle A, we know the opposite side and the hypotenuse. Opposite and hypotenuse are associated with sine. So to find angle A, you do the inverse sine of opposite over hypotenuse, 12 divided by 22. In your calculator, you put in 12, divide it by 22, and then do that inverse sine function. So second and sine. On most calculators, your calculator might be different, so play around with it.
Stop him for a second. So on my sketch pad, I drew a little triangle. Here's my right triangle. This is the angle that we're curious about. We know this angle right here. This is our 90, right? So depending on which side that they give you, that will dictate which trig function you use, sine, cosine, or tangent. SOHCAHTOA is a way to try to decide which function you're going to use. So if I'm looking at this angle right here, this is the opposite side from that angle. See? The opposite. So this is opposite. This is the hypotenuse relative to this little angle here. Okay? So I have opposite and I have hypotenuse. Right? And if you think about the mnemonic SOHCAHTOA, that would be so. So that means we're going to use sine. Right? And so what people will do, let's see if this will work, is they'll type sine, right? Now, what goes next is the angle, which we don't know, right? Right? Sine is opposite over hypotenuse. Of course, I need to make this bigger so it makes sense. There we go, right? And so what's this going to look like? Well, if you do, what is that going to be? The opposite side is 12. The hypotenuse is 22. So what happens is people will take 12, divide by 22, and they'll get some decimal here, right? And I'll do that real quick. 12 divided by 22 is 0.54545. So what you get is this weirdness that says sine of something equals 0.545454. Right? Now, you're not done. What did you find? You found sine of x equals something. Right? You're not looking for sine of the angle. This would be our unknown angle right here. You're not looking for sine of that angle. You're looking for the angle itself. And so what you do is, what I learned, and I'm not a math teacher, what I learned is you take sine and you chuck it to the other side. Put it over there. Okay? What you're left with is your unknown angle on this side. What happens over here is now you have, and see if I can write this without it being a complete mess, you have sine negative 1 of 0.5454. What a mess. Right? If I go back to his little video, right? Now you have sine negative 1 of that decimal. That will get you the angle that you want. Okay? There are 3 trig functions. It just depends on what sides of the triangle you have, and that will dictate which one you will use. I want to see what he says next.
You should get, the way you'll know you're doing this right, try this. Get out your calculator, try this one. 12 divided by 22 inverse sine, you should get 33.0557 degrees.
I did.
This means the angle A is 30 degrees. If you knew the adjacent side and the hypotenuse, then you do the exact same thing, but with inverse cosine. And if you knew both the opposite and adjacent sides, then you would use inverse tangent to find the angle.
Cool. So there you go. So it all depends on what sides.
AP Physics 1 concepts.
I'm just going to start again. It all depends on which side you have. Okay. So I use things. So if I change this, what if now this is 12 and that's 22? What do I know? In reference to this angle, 12 is the adjacent side, 22 would be the hypotenuse. So let's see, that is adjacent and hypotenuse, right? Adjacent and hypotenuse. So what is that? What trig function should I use? So that's ka. So ka toa. So in that instance, I'm going to use, oh my gosh, I cannot write with this. I'm going to use cosine. So depending on what sides you have, that will dictate which trig function you use. But thankfully, we only have 3 trig functions. Mr. Mitchell, you are the man.